Some viewers, good day, everyone. How's everything? It's really nice to meet you once again because I know you are here to grab something here. And here is a beautiful question for you. You know, I told you that project I was going to solve a lot of questions that will enable us to be stronger or come across any challenge as far as projectile is concerned. So this question will mark the conclusion of our calculations on projectile. I'm moving to the next topic. Guess the topic, don't worry, just stay tuned. Subscribe, click on the like, and let's enjoy the ride. Yeah. This is an external examination question, so it's a standard question. So I do pick them and then it is being solved. Now, here is a question before us. A bus X is projected from the platform RH. From the platform RH, this is a platform, so there's a platform higher, there's a platform lower. So there is a height between the higher platform and the lower platform. With a horizontal velocity of 14. So guess what? When they say horizontal velocity at this point, as far as projectile is concerned, they are telling us that u is equal to what? 14 meters per second. Yeah. If it takes 0.5 seconds for the ball to fall free from R, it takes 0.5 seconds. Now the time is what? T is equal to 0.5 seconds. For the ball to fall free from ROP, to fall from ROP, that is, it will go in a projectile format. I guess so. The velocity of movement is u is equal to what? 14 meters per second. Before gravity will start pulling it down to the point of P. Now, for the ball to fall free from arrow to P, this P, this arrow, so it's going with, so it's a projectile falling under gravity. The distance PQ is what? So what's the distance? So they are talking about the horizontal distance, which is x. So horizontal distance now, of course, is a very simple question. Very, very simple question. So what do you do when you see a question like this? X, horizontal distance is equal to u times t. Now, initial velocity times the time. So what is x? S is equal to horizontal distance, while u is equal to initial velocity, then t is equal to the time, let's call it time of flight. Yeah. So let's just substitute the formula. So x is equal to what? 14 times 0. X is equal to 7 meters. Yeah, it's very simple and straightforward. So distance from here to here, which is actually the range, is 7 meters. There is no need of using angle here and so let's go to the second question. Second question, question 2. When you see that a stone projected with a velocity of 50 meters per second. So the velocity is u is projected with the velocity, so u is equal to 50 meters per second. Yeah. From the ground level, from the ground level, hit the ground level. I think they want to say from. So now, first of all, we need to find what the horizontal distance, which is x, is equal to u times t. And now we now have hit the ground 5 seconds later. So now if you look at it very well, 5 seconds later, that means there's a point in time it leaves the ground, and there's a point, yes, the question is correct, the ground level hits the ground 5 seconds. So the time, the date is total time of flight. So time of flight. So there's a point in time that it gets to the maximum height. Are you getting? At that time it gets to the maximum height. So we can say T1 is equal to 5 divided by 2, which is what? 2.5 seconds. So it comes to the ground again at 2.5 seconds later. So what is the angle of projection? So we are taking into consideration now the time of flight. So what is the formula here? The stone. Yes, it comes from the ground and goes up and goes back to the ground. So it takes 5 seconds. So that means the time taken for the stone to get to this place, it took about 2.5 seconds. Now 2.5 seconds again to get to the we are making it 5 seconds. So it makes an angle. So the angle it makes to get to this maximum height is different from the angle it takes to go back again. So the time of flight we are considering here now is the time taken for the angle, the time taken for the object to get to this maximum height, which is going to be what? T, which is going to be what? U sine theta over G. Yes, adding is total time of flight now could have said T is equal to 2U sine theta over what? Over G. So now what are we looking for? We are looking for what? Theta. So let T be what? 2.5, because that is the time taken to get to the maximum height, 2.5 seconds. So we are going to have 2.5 is equal to, what's U? The initial velocity is what? 50 sine theta over 10. Yes, because our G is what? Our G is 10 meter per second. So please permit me to use this side of the board. So we are going to have the T, which is what? We are going to make the sine theta the square formula. So it's going to be sine theta is equal to 2.5 times 10 all over 50. So we're going to have 2.5 times 10 to give us 2.5 times 10 to give us 25. So 25 divided by 50 to give us 0.5. So sine theta is equal to 0.5. So theta is equal to sine shift 0.5. Guess what? To give us 30 degrees. So theta is equal to 30 degrees. Let's confirm it. Shift sine 0.5 give us 30 degrees. So the angle of projection is what? Is 30 degrees. So it's possible they might ask, what is the range? What's the range of this question? Now, if they ask us what's the range, of course, the range is now, because we are not taking into consideration we are taking into consideration the range now is going to be S, which is U times T.